So bit plane slicing, so it's a kind of point processing. Here what we are doing is we are transforming this digital image into a number of binary images. Okay, so the process of converting digital image into number of binary images called bit slicing. Okay, so we can see how it performs. Okay, so here we use the relation. So take the same example, 4 3 5 2 3 6 4 6 2 2 6 5 7 6 4 1. Okay, so for your understanding I am writing the same example again and again. F of x comma y, this is the input matrix. So here to convert this digital into binary form, first we have to calculate the number of pixels. Okay, so number of pixels already I have told you how to calculate the size of the image. We have taken the relation 2 power 3 equal to 8. Okay, so the power value says that number of bits in the image. Okay, so 3-bit image is the given matrix. Okay, now we can convert the given intensity values into binary, 3-bit binary values. Okay, so for L, how will you write the 3-bit value? 1 0 0 and 3 0 1 1, 5 1 0 1, 2 0 1 0 and 3 is again 0 1 1, 6 is 1 1 0, 4 1 0 0, again 6 1 1 0, 2 0 1 0 0 1 0, 6 1 1 0, 5 1 0 1, then 7 1 1 0, sorry 1 1 1, 6 1 1 0, 4 1 0 0 and finally 1 0 0 1. Okay, so I already told you in bit plane slicing what we are doing, we are taking the digital image and converting it into binary form, number of binary images. Okay, so here the most significant bit, center bit and least significant bit separately considered as 3 different binary images. Okay, so by dividing these 3 bits separately, we will get 3 different binary images. So if you consider the most significant bit MSB, so you will get 1 0 1 0, 1 0 1 0, then 0 1 1 1, 0 0 1 1, 1 1 1 0. This is a separate binary image, and if you consider center pixel, center bit, so you will get one more binary form, 0 1 0 1 and 1 1 0 1, 1 1 1 0, finally 1 1 0 0. And the least significant bit, that is the leftmost bit. If you consider the leftmost bit separately, you will get the separate binary form. Okay, so 0 1 1 0 and again 1 0 0 0, 0 0 0 1 and 1 0 0 1. Okay, so the process of dividing a digital image into number of binary image is called bit plane slicing. So in bit plane slicing, in this example, the size of the image is 3 bits. So we are converting the given intensity values into 3-bit values first. Then separately, we are separating most significant bit, center bit and least significant bit to get separate binary images. Okay. So we can review point processing. So under point processing, we have seen the relation S is equal to T of R. S is equal to T of R. Okay. So based on this relation, we have seen four different methods. First one is digital negative. So here we use the relation S is equal to L minus 1 minus R. And second one is thresholding method. Okay. So in thresholding method, what we have done is S is equal to L minus 1 if R is less than or equal to 4. Sorry, R is greater than or equal to 4, then 0 otherwise. And third method is clipping. So here we have used the method relation called S is equal to L minus 1 if R value lies in between 2 to 4 or 2 to 5. We can fix the value and 0 otherwise. And finally, we have seen bit plane slicing. In that method, we have to convert the digital form into binary form to get bit plane slicing. So first we have to calculate the number of pixels used in the image processing. Based on that, we can get number of binary images. Okay, so now we can move on to the image processing, image enhancement technique. So image enhancement is subdivided into three important domains. First one is spatial domain. Temporal domain or frequency domain. You can say frequency domain. And finally, combined so in the first domain, we are dealing with each and every individual pixel transformation, and in frequency domain what we are doing is to enhance the image, we are doing some Fourier transformation over the overall image. And the third method, that is combination domain, which uses both spatial and frequency domain. Okay, so here we are manipulating the individual pixels. Here we use the Fourier transformation over the whole image. And here we use both domains. Okay, so that is, we will do individual pixel manipulation, as well as we will modify the whole image by using the Fourier transformation. Okay, so under spatial domain, we have important image enhancement technique called histogram equalization. We are going to see it now. So before that, what is image enhancement? So image enhancement is a way of modifying or enhancing the features of one image so that it can be suitable for one particular application better than the original image. Okay, so when we use image enhancement, if you want to modify the features or quality of the image to fit into some application that will be better than the original image, that case we will do image enhancement technique. Okay, so under that image enhancement, we have seen three domains. First one is spatial, second one is frequency domain, third one is the combined domain. So as I told you earlier, spatial domain here we will manipulate each and every individual pixels to get the modified form, and the second one is frequency domain. Here we use the Fourier transformation methods to modify the overall frequency or intensity values are of the input image, and finally combined domain, which uses both spatial and frequency domain features. Okay, then under spatial domain, one of the important image enhancement techniques called histogram equalization. So we are going to see histogram equalization with one example so that you can understand clearly. First of all, we are going to see one problem under histogram equalization method. Perform the histogram equalization for an 8x8 image shown below. So the data given is in the table. So gray level, that is the intensity value of each and every pixel and number of pixels. So number of pixels is a number of occurrence of this gray level value in an image. Okay. So the given values are 0, 1, 2, 3, 4, 5, 6 and 7. So the number of occurrence of the intensity value 0 is 9. 9 times it occurs in the image matrix, and 1 it occurs 8 times, 2, 11, 3, 4, 4, 10 and 5, 15, 6, 4 and 7, 3. Okay, so this is a given table. So for that we are going to perform the histogram equalization for the given data. So this is in the problem statement they have mentioned it's a 8x8 image. So these are the intensity values in the 8x8 image, 0 to 7. The values ranges from 0 to 7. So the number of occurrence of each intensity values is given in the table, that is number of pixels 9, 8, 11, 4, 10, 15, 4, 3. Okay, so here what we are doing is we are modifying this given input image into output image. So this is also a kind of point processing technique, but here we are taking the input and applying some mathematical calculation over it to get the modified form, that is g of x comma y. So first, for the given input image, we can draw the histogram chart. Okay, so we can consider gray level as x-axis value, and number of pixels is a y-axis value. Okay, so the gray level values varies from 0 to 7. So 0 to 7, right? 0, 1, 2, 3, 4, 5, 6, 7. And number of pixels are 9 to 15. The value ranges from 9 to 15. Sorry, 3 to 15. So the least value is 3 and the highest value is 15. Okay, so if the gray level value is 0 and the number of frequency is 9, how can you represent 0 and 9? Okay, so first plot 3, 4, 5, 6, 7, 8, 9, 10, 11, then up to 15, 12, 13, 14, 15. Now 0 x-axis and y value is 9. So mark it here. And for the intensity value 1, number of occurrence is 8. So mark it here. And for the intensity value 2, the number of occurrence is 11. And for the intensity value 3, the number of occurrence of intensity value 3 is 4. Finally, for 4, the number of occurrence is 10. Then 5, 15. 6, 4. And 7, 3. So this is a histogram of given input image. Okay. So now we are going to do histogram equalization. Finally, we will get the modified histogram for the output image. Okay. So the histogram equalization, which involves 4 important steps. First, we have to calculate the PDF, that is probability distribution function. Second, we have to calculate cumulative distribution function. And finally, we have to calculate the value multiplied by the maximum number of intensity value. And finally, we can take the round of value. So we can see it using the table. So for the given input, we are going to calculate the histogram equalization. Okay, so first write the gray level and number of pixels in the table. Zero, 1, 2, 3, 4, 5, 6 and 7. And number of pixels So number of pixels is the number of occurrence of this intensity value in the given input matrix. Okay, so this is represented as n of k. Okay, so number of pixel is represented as n of k. Here the values are 9, 8, 11, 4, 10, 15, 4, 3. So as I told you, in histogram equalization, first we have to compute PDF. So what is PDF? So PDF is a probability distribution function. Okay, so this PDF can be calculated. This PDF can be calculated using the formula nk divided by n. So you know what is nk. Nk is the number of pixel, and what is n? N is the total number of pixels in the image matrix. So if you add these values, you will get 64. Okay, so if you add all these values, 9 plus 8 plus 11 plus 4 plus 10 plus 15 plus 4 plus 3, you will get 64. Okay, so we can calculate probability distribution function using the formula nk by n. So this is nk value. If you divide this value by 64, you will get PDF value. Okay, so first 9 divided by 64, you will get 0.141, and second value 8 divided by 64, you will get 0.125, and third one 11 divided by 64, you can use calculator. 11 divided by 64, you will get 0.172, and similarly if you divide all these values by 64, you will get these values: 0.0625, 0.156, 0.1234, then 0.0625, and finally 0.047. So we don't want this table because we know the value of gray level and number of pixels. Okay, so first we have calculated the probability density function. Then now we can calculate cumulative density function. So this cumulative density function can be represented using the symbol S of k. Okay, so the gray level values are given in the table. In the problem statement, they have given the gray level. The number of pixels are given. First we are calculating the probability density function. Then again we are calculating the cumulative density function, that is represented as S of k. So the cumulative density function can be calculated. First what we are doing is we are writing the same value here. So for the first pixel level, so for the first pixel value, we are taking the same value as a cumulative value, that is 0.141. But for the next one, what we are doing is we are adding this value with the PDF value of gray level. So 0.141 is added with 0.125. You will get the new cumulative CDF, cumulative density value. Okay, so here we will get 0.266. What we have done is, first I have taken the same value here. PDF of first gray level is taken as the CDF of first gray level, and for the successive values, what we are doing is we are cumulatively adding the previous value. Okay, so this value is added with the next gray level PDF, and you will get the new value. Then again this value is added with the next value, that is 0.266 is added with 0.172, you will get 0.438, and again add 0.438 with this value, you will get 0.5005. Again add this value with the previous value, that is 0.156 is added with 0.5005, you will get 0.6565, and again add this value with previous cumulative value 0.6565, you will get 0.8905. Again add this value with the previous cumulative value, you will get 0.953. Finally, if you add these two values, you are getting 1 as a result. Okay, so we have calculated the cumulative probability density function. Okay, so next step is we have to multiply this Sk with 7. Okay, so what is 7? What is 7 here? So already I have told you how to calculate the L value, right? So here L means 7 means that L minus 1. So first we have to calculate the L value. How will you calculate L value? First we have to write all the intensity values in the form of 2's power. So here also we use the intensity values which ranges from 0 to 7. So if you write all these values in 2's power, 2 power 0 is equal to 1, 2 power 1 is equal to 2, 2 power 2 is equal to 4 and 2 power 3 is equal to 5. Sorry, 2 power 3 is equal to 8. So the maximum intensity value here is 7. So 7 is very closer to 8 and lesser than 8. So I am taking this relation. So in this relation, 3 is the number of pixels in the input image and 8 is the L value. So if 8 is L value, then L minus 1 is 7. Okay. So here the formula is Sk multiplied by L minus 1. Okay. So Sk value is cumulative distribution function. So multiply this value with 7, you will get you will get this column values. So 0.147 is multiplied with 7, you will get 0.987. Similarly, multiply all these values with 7, you will get the following values: 1.867, 3.066, then 3.5035, 4.5955, then 6.233, then 6.671, finally 7. So in the last column, we are going to find the histogram equalization of given grayscale level. Okay. So the histogram equalization for the given gray level is calculated by taking the round off value. So 0.987, so the round off value is 1. Here 1.8, it will become 2. 3.0, that is 3. 3.5, 4. 4.55, then 6.26, 6.67, and again final value is round off value 7. Okay, so if you take this column 1, 2, 3, 4, 5, 6, 7, 7. So there is a repetition. So for this histogram equalization value, the number of occurrence. So the number of occurrence of 7 is 3 and 4. So the new number of occurrence is 3 plus 4, 7. Okay. So after calculating all these values, so in this what we have done, from the problem statement I have written the gray level, then number of pixels, then I have calculated PDF value. From the PDF value we have calculated the CDF, that is cumulative distribution function. Finally we are multiplying this value with L minus 1 value, we are getting this table, and at the end we are calculating the histogram equalization by taking the round off value of this Sk into L minus 1. Okay, so and if you identify any repetition or duplication, you can add the number of pixels, add the number of occurrence of same gray level value to find the number of occurrence. And now from this table we can draw the histogram table. So here also the pixel level, pixel grayscale value level, gray level, and the number of pixels. Write it here. So the pixel values in the histogram equalization, the pixel values are 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. And the number of pixels, that is n of k, is for 1 9, for 2 8, for 3 11, 4 it is 10, for 4 it is 4, for 5 it is 15, and for 6 it is 4. For 9, 8, 11, 4. For 5 it is 10. For 6 it is 15. For 7 we have added 4 and 3, you will get 7 again. Okay, so by using this histogram values, again we can plot the histogram graph. So here also the x-axis represent gray level and y-axis represents number of pixels. So gray level ranges from 1 to 7. And number of pixel ranges from 9 to 15. Sorry, 7 to 15. Up to 15. Okay. So for the gray level 1, the number of pixels are 9. Plot it like this. Then 2, 8. Then for 3, 11. Then for 4, it is again 4. Then for 5, it is 10. For 6, it is 15. And for 7, it is again 7. Okay. So this is a way of converting a given input image into histogram equalization image. Okay. So the histogram equalization, which involves 3 major steps. First, we have to calculate the PDF. So to calculate the PDF, we should have the number of pixels. So that is nk. From nk, we can calculate n value. That is the total number of pixels in the input image. Okay, so after calculating the PDF value, we can calculate the cumulative distribution function that is represented as S of k. So here the first value, we how we are calculating the CDF? We are taking the same PDF as CDF for the first value. For the all other remaining value, we are taking the previous CDF and add it with the PDF value. We will get the cumulative CDF. Okay. Then the next step, what we are doing is we are taking this SK and multiply with L minus 1 value. So in this example, L minus 1 value is 7. So finally, we will round off all this SK into L minus 1. We will get the histogram equalization.